1.2, rates of change. Here we go. I need some readers up in here today. And Ella, oh my gosh, thank you so much for volunteering. Go.
In topic 1.1, we learned that the phrase rate of change is synonymous with the word slope. So positive rate of change indicates that a function has a positive slope.
Goes up.
The function is increasing, and the negative rate of change indicates that a function has a negative slope.
It's going down. All right, cool. Keep going. You're doing great.
In AP Pre-Calc, we will define the rate of change of a function at a point at which the rate the output values would change if the input values were to change at that point.
Good. Keep going.
Later in AP Calculus, you will call this the instantaneous rate of change. The concept of a function changing instantaneously is called a
Derivative. Yep.
and is quite challenging to understand without first learning the foundational ideas found in AP.
All right, so we're going to talk around that, basically. We're going to kind of talk about it, but we're going to kind of talk around it in this class. All right, so this is really cool because we get to learn some of those concepts right now. All right, pick somebody.
In AP Pre-Calc, we are unable to find the rate of change of a function at a given point. This will require calculus, but we need to determine if the rate of change at a given point is positive, negative, or zero. We will also need to be able to compare the rates of change at two distinct points.
All right, cool. So what did we say going up was? That was a what kind of rate of change? Positive. Okay, we said it was an increasing function, but it's a positive rate of change. And negative is a what? And going down means what? It's a negative rate of change. It's a decreasing function. All right? And so at the instant of point that you're at the top of the peak or the bottom of a valley, you're not moving up or down. Does that make sense? Because what's increasing mean? It's going up. And decreasing means going down. But what's that instantaneous that you're at the top of a mountain? The top of a roller coaster? Are you going up or down? No, at the very instant, you're going neither. All right, and so that rate of change is zero. So if you think about this little roller coaster right here, what kind of rate of change is this one at t sub 1? This is positive. The rate of change is positive. All right, it's an increasing function there. But what's it doing at 2? It's 0, right? And then right here at 3, it's what? It's a decreasing function, but it's a what kind of rate? It's a negative rate. And then down here, the little cart's not there, but what would it be at the bottom of the valley? It would also be 0, because then it would be going from negative to positive rates of change. But right at that instant, it is 0. Pretty good? All right. And then a fun fact for you. Who wants to write our fun fact? Oh my gosh, Trace, go for it.
The fastest roller coaster in the world is the Formula Rossa in Abu Dhabi, United Arab Emirates. Built in 2010, the coaster reaches a maximum of 149.1 miles per hour. For comparison, the average speed for the 2008 Indy 500 was only 143.6 miles per hour.
All right, so Mu Alpha Theta is going to take our new trip to there instead of Busch Gardens. Congratulations. We're gonna fly there. It's going to be great. All right, here we go. Example 1. All right, so this figure shows function f. Order the rates of change of f from least to greatest, okay? And so let's talk about the rates of change of these things. Well, what do we know about the rate of change of A? That's positive. Agree? See how it's going up? It's a positive rate. And then what's B doing? It's negative, right? And then what's C doing? 0. Does everybody see that? And so what's my least to greatest? So what's my least? My least. B. Okay, so that's my negative one. So that's my B rate. And then what's next? What's my next least? C. Okay, my C rate, because that thing is what? 0. And then what's my greatest? My A rate. All right, because that's my only positive. All right, let's keep moving. All right, so on this one, we have 4 labeled points. Which of the following is the rate of change of G, the least? So now I'm finding the least rate of change. All right, okay, so the rate of change being the least. Well, what's the least on this one? Which one? D as in dog, exactly. Now, D as in dog is a negative rate of change, right? But what other one's a negative rate of change? C is also a negative rate of change, but it's not as slopey. as D. All right, maybe D would be a -5 rate and C would be like a -1 rate. Is everybody following me on this? And so D wins, all right, or actually loses. You know how you look at it. All right, cool. We're going to read some more up in here. Who was my last reader? Was it Mary? Pick somebody.
Another important concept that we'll use throughout AP Pre-Calc is the average rate of change of a function over an interval.
Keep going.
The average rate of change of a function over an interval is the constant rate of change that yields the same change in the output values as the function yielded on that interval. It is the ratio of the change in the output values to the change in the input values over that interval.
What was that? What did that say? The ratio of change of the output values to the change of the input values. What's a ratio? Huh? A fraction. I love that. All right, it's either a fraction or a colon, right? But we're going to talk about a fraction. And so what's on top is the change of the output values. Well, what in the world's the output values? What do we normally say that is? Our y. So it's our change of y over, because it's a ratio, over what? Change of x, because those are our input values. And to break it down even further, we might call it y2 minus y1 over x2 minus x1. What is that? That's our slope formula. So this is the way I want you to remember it. Average rate of change is purely algebra slope. That's what we're going to do the entire day. All right? So average rate of change, what do I want you to think of? Algebra slope. Okay? In calculus, we get instantaneous rate of changes. However, we're going to kind of brush around it a little bit here. However, we can't actually find it unless we know calculus. All right, that's next year. All right. So, average rate of change is what? Algebra slope. All right, fantastic. All right, we're going to move. We're going to move. So, let's look at this example. All right. It says the figure of the graph of the function of the following, which interval is the average rate of change of h the greatest? All right, what's an average rate of change again? Algebra slope. All right, and so I need to go from 2 to 3. And so where's my value of 2? When x is equal to 2, what's the y value of it? 6. So it's right there, isn't it? And then where does 3 go? 6. Well, what's the slope between 2 and 3? 0. It's a 0 slope. Good. Perfect. You did great. All right. And now let's do 3 to 5. All right. We'll do this one in red. So 3 is right here. Everybody agreed. And then where's 5 at? About-ish where? 4. Okay. A little less than 4, sure. All right. And so it's right there, right? And so what kind of slope is in between those two? It's a negative slope. So who's winning right now? 0 wins before negative, right? 0 is greater than a negative, all right? So now let's go 5 to 7. And so 5 we decided was right there, and now let's go to 7. Well, where do we think 7 is? It's all the way up as 6, all right? And so when we connect those two, is that a positive or a negative slope? That's a positive slope. That's a positive rate of change. Okay? All right. And then how about 7 to 8? Well, where's 7 to 8 going? 7's up here at 6, and where's 8 at?
3.
At 3. And so what's going on with 7 to 8?
Negative.
That's a negative rate of change. So which one's the greatest rate of change? An average rate of change?
C.
C. All right. So the only one that's positive, my average rate of change is the greatest. All right. Pretty good? All right.
The graph of the function y equals f of x in the xy plane always has a negative rate of change. Which of the following directions for the variables x and y would best model the function f?
All right. Fantastic. So what's our input values? If we have y is equal to f of x, what's our input value? X, and then our output value is y. And we need a what kind of rate of change?
Negative.
A negative rate of change. Okay? So let's see their relationship between it. So let's look at A. The age in years of a young child, and then the output is the height in inches of the young child. Well, is that a positive or negative rate of change? That's a positive. All right. Hopefully it's not a Benjamin Button case. All right. And so hopefully as you grow older, for a young child, you get taller. Make sense? That's positive. All right. And so let's look at B now. It says the total number of points scored in a basketball game, and then the output is the time remaining in seconds in the game. Is that going to be a positive or negative average rate of change? Negative. All right. Because hopefully as time dwindles down, there are what? More points. We don't take away points in basketball. All right. And so that has a negative rate of change. All right. So I want to keep going with them though. So let's look at C. All right, so C, the X is the time in seconds since a ball is thrown straight up in the air, and Y is the height and feet of the ball. What kind of average rate of change is this? It's positive at the beginning, right? But then that gravity happens, I hope. It probably things not going up the entire time, is it? At some point, it's going to be what? Negative 2. Okay, but anyway, we're going to call this one not it because it's both. All right, and then D, the radius of a circle and then the area of that circle. As the radius gets bigger, what do we know the area is going to also do? Get bigger. All right, so that's a positive rate of change. So that's why. All right, so let's look at number 5. This will require a calculator. All right, here we go. The function k is defined by that. Which of the following of k is correct? Now, let's read this. K has a positive rate of change. K has a negative rate of change. Well, what does that mean for a positive rate of change? It's going up. And then a negative rate of change is? It's going down. Does anybody know what this graph exactly looks like? Me either. So let's graph it. All right. And so now it says when is the positive rate of change and when it's negative. So where is it positive? From like here to here, right? It's a positive rate of change from there to there. And so we kind of need to figure out this x value at the top. All right, and this is how we're going to do it today. Okay, I'm going to kind of go baby steps with you as we go along. So you see this little trace button? It's the fourth thing from the top. All right, little trace button. So I want you to press the little trace button. And I want you to kind of scroll to the top of that peak. All right? And so whereabouts is that? 2.4, 2.5, somewhere around there, right? And so it has a positive rate from negative 10 to about 2.4, 2.5-ish. All right, that should be sufficient enough for us right now. And so when do I have a negative rate of change from negative 10 to 2.4, 2.5-ish? Does any of them say that? When do I have a positive rate from, is it C? No, none of them say that, do they? So maybe I need to look at a negative rate. So if I have a negative rate, what should be my negative rate? What's describing this part? The 2.4 thing to what? 10, exactly. So what says that now? D. All right. So that's how we can graph a function that we don't know what it looks like. Right? We can use those procedures right there. All right.
The table gives the life expectancy of U.S. females born in a given year over successive 50-year intervals. Over which of the following intervals is the average rate of change in life expectancy the greatest?
All right, so an average rate of change, the greatest. All right, well, what's average rate of change again? Slope. It's algebra slope, right? And so if I need to find from 1800 to 1850, this is like my input value is my birth year, and my output value is my life expectancy. All right, not mine because I'm not a female, but anyway. All right, and so I'd just do Y2, which is this part, my output. So I'd have 46.10 minus my other output of 41.24 over 1850 minus 1800. And then I'd type that into my handy dandy calculator. And what do we get? 0.0972. All right, in this class, and as well as AP Calculus, we are going to 4 decimals. We're going to go to the 10,000ths place every time, all right, unless specified. All right, that's the one we're going to go to. All right, and so now if I go from 1850 to 1900, well, what would I use there? 53.63 minus 46.10 over 1900 minus this 1850. And so then I'd press that into my handy dandy calculator. And so my average rate of change is 0.1506. All right. And so now we got to do part C. And so part C, I'm going to do what? 70 point. So if I'm going 1900 to 1950, 70.65 minus 53.63 over 1950 minus 1900. I put that into my handy dandy calculator and I end up with 0.3404. And then I do the same thing for 2000. Now that I have all of these average rate of change, which average rate of change is what again? Just what? Algebra slope. It's just algebra slope. And so, what is my highest average rate of change? C. All right, 1900 to 1950. I'm sure in some case there was the large medical discovery in that time in which the female population got to live longer. All right, now we are living longer now, but there's a higher jump then. All right, that's what that means. All right, pretty good? Cool. All right. Trace, what are the directions on part A?
Find the average rate of change for the following functions on a given interval. Show all work.
Love it. All right. And so all we're finding is algebra slope. Okay, we're just finding algebra slope. So my interval on this one is 2 to 12. Those are my what values? The x values. Well, what else do we need to find? The y values. In this case, are h of x values. All right. And so we're going to set this up as h of 12 minus h of 2. Do you see how that's like y2 minus y1? And then it's over what? 12 minus 2. So that's my like x2 minus x1. All right, and now we just have to do a little bit of math. All right, so if I need to substitute in 12, we can do this. Ready? So 4 times 12, I'm just substituting in 12 for x. So 4 times 12 is? 48. 48 plus 1. 49. And then we square root it and we get 7. So h of 12 is 7. Minus, now I need to find h of 2. So now if I substitute in 2, 4 times 2 is 8 plus 1. Square root it, 3. And then it's over 12 minus 2, which we call 10. And so 7 minus 3 is 4. So I have 4/10. You can simplify it if you'd like. So we end up with 2/5. All right. So the average rate of change on the interval 2 to 12 of that function is 2/5. Okay. And so that would actually have a slope of 2/5 between those 2 points. Make sense? All right, cool. Let's do it graphically now. So that was analytic or algebraically. Now we're going to do it graphically. All right, graphically is actually easier in my opinion. So now we're going to find the average rate of change from 1 to 6 of this function. All right. And I'm going to write out the algebra slope, but I'm not actually probably going to do too much of it, but we're basically going to do it without doing it. All right, so we got p of 6 minus p of 1 over 6 minus 1. That's really what we're doing. Okay, so what's p of 6? I go to my x value of 6, and my y value would be what? 1. So p of 6 is 1. Minus, now I need to find p of 1. And so p of 1 is what? Negative 2. And then it's over 6 minus 1. So we'd have 1 minus negative 2. What's 1 minus negative 2? 3. Good. Over 5. So guess what my slope between those 2 points was? 3/5. And if you could just look at it graphically, slope is really rise over run, right? How much did it rise? How much did it run? Look at that. All right. See how we can do that? So on graphically, do I actually need you to show the algebraic part of it? No, you can count if you want. I don't care. All right. So anyway, there's another way to Tampa if you'd like. All right.